Hello, everyone. Hello, everyone. Please kindly share the link. All right. So please share the link. I'll start within 5 minutes from now. Thank you. Okay. I will start around 6:10. So please kindly share the link. Okay. So please, if you are in, kindly type hello. I am going to start exactly at 6:10. Going to start exactly at 6:10. All right. So I want us to start. I want us to start. So those of you who have joined, please, we are just about starting, and then we are going to start from the parallelogram law. Okay. We are going to start from the parallelogram law. Okay, so what is the parallelogram law? All right, so what is the parallelogram law? Um, so the parallelogram law is saying that whenever you have two forces, um, so whenever you have two forces, you can add them using the parallelogram law. Okay, so I want us to start with this problem. So in this problem, we have been given two forces of magnitude 200 newtons and then what? 250 newtons. So how can I add these two forces? Okay, so how can I add these two forces? So I'm going to use the parallelogram law, which states that whenever I have two forces, I could just add them. So with this problem, this is how we are going to start with. So I have 200 newtons, and then I'll draw this 200 Newton force right here. Okay. So that is our 200 Newton force. And then I'll draw a line here. All right. So this is the 200 Newton force. Uh, then this is our 250 Newton force. Okay. So how can we add these two forces? It's pretty much simple. So what you are going to do is that, but before we continue, let's note the angles. So the 200 Newton force is making an angle of what? 26 with the y-axis. Okay. So it means that over here it's going to be 26. So here is 26. Okay. This is 200 Newtons. And then the angle here is 26. Now the angle that the 250 is making with the horizontal is also 14 degrees, right? Okay. So then how can I find the resultant? So that is pretty much simple. So I will just draw parallel to the 250 newtons, and then I'll draw parallel to the 200 newtons. So basically what we are doing is we are drawing a parallelogram, and then the parallel sides are perpendicular, the parallel sides are equal, but they are opposite to each other. All right, the parallel sides are equal, but they are opposite to each other. So that's why we are calling it the parallelogram. Now if I draw a line to join the diagonal, then I will have this as my resultant. So that is all about the parallelogram law. Please, any question up to this point? Okay, so how can I add these two forces? I'm going to use the parallelogram law, which states that whenever I have forces, I could just add them. This problem, this is how. Please, any question? Any question up to this point? Okay, so let's calculate the resultant now. All right, so if I want to calculate the resultant, then I need to also know the angle between the two forces. All right. So now this one is 26, and then this one is 14, right? So what will be the angle here? All right, so it's going to be, we know from geometry that the total angles at this point here is what? 90 degrees, right? So now if this is 90 degrees, so now if that is 90 degrees, then what can I say? So I can say that if I add all the angles, it's going to be 90 degrees. Is that right? All right. So then from here, so I'll pick my calculator. All right. So this is the resultant. And then, sorry for that. So this is 14 degrees. This is 26. So then this angle is nothing but, so 26 plus alpha plus 14 degrees. So let's say this angle is, say, alpha, the angle between 200 and 250, right? Should be equal to, so 90 degrees, all right? Okay, so then I can say that alpha is going to be 90 minus 26 minus 14. And what is that going to be? So then that's going to be 90 . So that's going to be 90 minus 26 minus 14. And that is what? 50 degrees. So what this means is that the angle over here between the two forces is what? Is 50. All right. So the alpha here that we want is what? 50. All right, so now knowing that alpha is 50, then what can we say? So now we want to use the parallelogram law, but let's try to extend the angle. So now if I try to draw a straight line here, from geometry, what can we say? Since this line of action is still the 250 newtons, then I can say that this is still 250 newtons, right? But I just saw that the angle between the 200 and the 250 is what? Is 50 degrees. All right. Okay, so then what will be this angle here? Now that angle over there is just going to be 180 degrees minus 50, right? Why? Because the angle on a straight line will add up to what? 180 degrees. So we expect that the angle here is going to be what? 180 minus 50 degrees. And what is that? So let's pick our calculators and let's do that. 180 minus 50. And what is that? So that is 130, right? So that means that the angle there is 130 degrees, isn't it? So then if the angle is 130, then I can take the triangle out. So now I want to take that triangle out, okay? I want to take that triangle out. So it's going to look like this. Our resultant is here. We don't know the value, okay? And then I have a force here, which is 250 newtons. And then also I have a force here. So there is a force here, which is 200 newtons. All right. And then we just said that the angle here is 130 degrees. All right. So please, any question up to this point? Any question up to this point? Please, any question up to this point? All right. So at this juncture, we are going to use the triangle rules, okay? So we will use the cosine rule and then the sine rule. Yeah. Okay. So now we are going to use it. So using the cosine rule, we can say that the square of the resultant is equal to the square of the other sides, which is 200 squared plus 250 squared minus 2 into 200 into 250 cosine the angle which is opposite to the resultant. And now this angle is what? 130 degrees. All right. All right. So now one thing that I want you to also understand is that if you are also interested in just the magnitude or the resultant, you could also use 200 squared plus 250 squared minus 2 into 200 into 250. But this time around, here is going to be plus, then you can use cosine 50 degrees. All right. So these two equations are the same. These two equations are the same. These two equations are the same. Okay. So these two equations are basically the same. Right? Now, so let's pick our calculators and then find the value of the resultant. Okay, so please, any question up to this point? Any question up to this point? So basically, we are using the parallelogram law, and then we are using the cosine rule. Yes. Please, any question up to this point? Any question up to this point? All right. So let's pick our calculators, and what is going to be the value of the resultant? What is going to be the value of the resultant? Please, someone should tell me the answer. If you have your calculators with you, kindly punch the values. Okay. So let's do it together. So it's going to be, you can use any of them. So the square root of, 200 squared plus 250 squared. Okay. All right. So 200 squared plus 250 squared. Okay. And then minus 2 times 200 times 250 and then cosine of cosine of 130. Cosine of 130. Yeah, okay. So what is it then? All right, so the answer is going to be okay. So what is the answer then? Has anyone got an answer yet? All right, so please, I'm waiting for you guys. So you are going to get 408.36. 408.36 newtons, and that is the resultant. Now someone should try the second equation, which is plus, and then this one is cosine of 50. Now why are we using this one? So let's justify and let's try to understand what we are doing here. Now essentially we can see that the angle between the two forces was what? 50 degrees. So this is one of the tricks. If you are solving an exam question and you want to be very fast, let's say you've been asked to find the magnitude, this is how you are going to go about it. If the angle between the two forces is known, then please, this side is going to be plus, and then this is going to be cosine of 50. That's all. Okay. But then, but we are not done, okay? We are not done. The last thing is to find the angle the resultant force will make with the horizontal. Now, we have to pay attention that, okay, so let's call this angle, let's say theta. Now, this, the 250 Newton force is making an angle of what? 14 degrees with the horizontal. Is that right? But to find the angle, the force, okay, so angle, the resultant force mix with the x-axis. Okay, so now we are interested in the angle the resultant force makes with the x-axis, and that angle is nothing but that angle is nothing but theta plus 14 degrees. Okay, so then how can I find theta? So basically we want the whole of this angle from the resultant all the way to the x-axis. Don't forget that this one is 250 newtons, but we need this one. Okay, we need the whole of this. Is that right? So essentially that is going to be what? So first of all, let's find theta, then we add it to 14. So we are going to use the sine rule. All right, so we are going to use the sine rule. And what is the sine rule? Now the sine rule is saying that we can use the sides of the triangle and the ratio between their sine of the angles opposite is a constant. So in other words, let me write the sine rule. So sine 130 divided by r is going to be equal to sine theta divided by 200. All right, so now basically what we are doing is that so sine 130, look at this, is the angle sine 130, and then divided by r. Okay, so divided by this r, and then sine theta, which is the angle we want, divided by the side which is opposite to theta, which is what? 200. All right. So now to find theta, we can say that sine theta is nothing but so 200 sine 130 divided by r. And but what is r? R is 408.36 newtons. Okay, so what do we get? Okay, let's solve it straight away. It means that theta is going to be the tan inverse. All right. So theta is going to be tan inverse, sorry, sine inverse, sorry. So the sine inverse of sine inverse of 200 sine 130 divided by 408.36. Is that right? Now what is it then? Okay, so let's pick our calculators. Okay. So now what is it then? It's going to be okay. Please, anyone with the answer? Okay. So the answer is going to be the sine inverse of 200 sine 130 Okay, so 200. Sorry, let me do it again. So the sine inverse of 200 sine 130, and then I'm going to divide this by 408.36. And what is that? So 22.035, or let's say 22.04. 22.04 degrees. All right, so now if I want the total angle, then it's going to be 22.04 plus 14 degrees. And what is that? So 22.04 plus 14, and that is what? So that gives us 36.04. And so that is the angle. So this question has been solved. So now we have the resultant force R, and then we also have the angle which the resultant force mixed with the x-axis, and that is 36.04. Any question up to this point? Okay, so if you have a question, please drop it now. And then you know what? I have solved several examples of this question. So I will leave the link below so that you can watch. Okay, I have solved more than 10, I think 15 questions on the parallelogram law. I will leave the link below so that you can watch. But for the purpose of time, I want us to now look at when I have two or more forces. Let's say you have several forces, okay? So now this one was just when you have only two forces, okay? Now let's say you have two forces, three forces, and more than that. What do you do, okay? But then if you have a question, you can type it, then I'll look at it. Okay, please, if you have a question. All right, so, okay. I think we can continue. Now, if you have learned something new, you can type. So you can type "thank you, sir" or something like that in the comment section. At least you have learned something. All right. Let's go to several forces. Okay. Okay. Sorry. Okay, so let's continue with this problem. Now we have several forces. All right, so basically, so we've been asked to determine the x and y component of each force. Okay, so how do I go about this? Okay, so we've been asked to determine the x and y component of each force, and then so first of all, we are going to start with the resolution of the forces, and then we are going to start with the All right, so let's move to resolution of forces. So determine the x and the y component of this force. All right. Okay, so let's start with the 80 Newton force. All right. Let's start with the 80 Newton force. So we are going to resolve this force into x and y components. Is that right? So then, with the 80 Newton force, by the way, the x component of the force is going to be what? Okay, so before we start, let's do this one. I think let's do this. So we need to assign a convention. This is x, this is y. Positive, positive. Okay. So the x component is going to be 80 cosine 40 degrees. Right? Okay, let me do it this way. So essentially there is an 80 Newton force and I want to resolve along the x, and then also I want to resolve along the y. Okay. So now the x component is going to be cosine by the y, but then the y component is going to be sine. Is that right? So the x component is going to be 80 cosine 40 degrees. Is that right? And what is that? 61.28, right? Okay. So then Fy is also going to be 80 sine 40 degrees. And what is that? So 80 sine 40. So basically that's also 51.42. Yeah. So 51.42 newtons. Very good. All right, so we have the x component, we have the y component of the 80 Newton force. Now, let's move to the 120 Newton force. So we are done with the x and we are done with the y. All right. So let's do the 120 Newton force. Okay, so with a 120 Newton force, okay, so with a 120 Newton force, what is it going to be then? All right, so our X component, uh, our X component is going to be what? Watch this. Watch this. You can see that I have 30 degrees and 40 degrees here. Yeah. Now, if I add 30 to 40, I'm going to get what? 70 degrees. Is that right? So basically, you can see this as 30 degrees plus 40 degrees, which is what? 70 degrees. Is that right? So we are, so now ignore. So ignore that there is nothing like 80 Newton here. Yeah. So you add 30 to 40, you're going to get 70 degrees. So now Fx is going to what? Uh, so picture this as we have 120 somewhere here, and then we are resolving into x and then y. Okay. So picture it as something like this. And then this is like 70 degrees. And then this is like 120 newtons. Yeah. Now the x component is going to be 120 cosine 70 degrees. Is that right? And then what is that? Okay, so let's pick our calculators one more time. So 120 cosine 70. Is that right? So 120 cosine 70. 120 cosine 70 is what? 41.04. Is that right? Okay. Let's do the y component. Now, essentially, it must be understood that one thing that you have to take care of that, you know, all the time, the fx and the fy are such that if the angle is opposite, then it is sine. And if the angle is adjacent, then it is cosine. Is that right? So please bear that in mind. Whenever you have the force and the angle, whenever the angle is opposite, then it's going to be sine. But whenever the angle is, whenever the angle is adjacent, then it's going to be cosine. All right. So 120 sine 70. What is that? Let's pick our calculators. All right, so let's pick our calculators. 120 sine 70. What is that? I want you to also pick your calculator and convince yourself that whatever we are doing here is correct. All right? So please, let your calculators be with you so that you can also confirm all the values we are getting here. Is that right? So that is our x component, and then that is our y component. All right. Now, finally, we have 150 Newton here. Is that right? Okay. All right. So we've got our x, and then let's move to the 150 Newton force. Okay, let's move to our 150 Newton force. Okay. So then with the 150 Newton force, let's watch something here. There is an angle, and this angle is what? 35 degrees. Okay. But watch this. You can clearly see that um what do you see here? 35 degrees, isn't it? But watch this. If I try to resolve the 150 Newton force, it will get X component here, and then it will get Y component here. Now, interestingly, what this means is that the X component um, all right. So then all right, yes. This is Fx, and then this is what? Fy. Okay, good. So now let's okay. So Fx is what? So Fx is going to be you know, okay, watch this. Please watch this. This is what? 150 newtons, and it makes an angle 35. So the S component is what? 150 cosine 35, isn't it? But interestingly, the direction of the x-axis is towards the negative x direction. And for that matter, you are going to negate the x. So in other words, it's going to be minus 150 and then cosine of what? 35 degrees. Okay, so what is it then? Okay. So what is it? So essentially, it's going to be (150 cosine 35), which is minus 122 point what? 87 newtons. And then Fy is going to be so let's go back. So then Fy over here, since the angle is opposite to the y, is going to be what? 150 sine 35. But you see that for this one, the y-axis is going up, isn't it? And now since the y-axis is going up, then it's going to be positive. All right. So Fy is what? 150 sine 35. So okay, let's punch this one. 150 sine 35. And that is what? 86.04. All right. Okay, so now this is what we are going to do. We are going to sum all the forces along the x, and then we are going to sum all the forces along the y. So we are going to start with the x-axis, summation of forces along the x, and then the convention is that every force towards the right is positive. Is that right? So okay. Now we go back to the first one. It was what? 61.28, isn't it? Then we add it to what? 41.04. So let's do that. 61.28. That was the first value. Then plus what? So plus 41.04. Then minus what? 122.87. All right. Okay. So now what is the answer? Again, let's pick our calculators. So we are going to sum everything there. So what is it then? 61.28 plus 41.04 minus 122.87. So we get the x component to be minus 20.55, right? Minus 20.55 newtons. Okay, let's do the y. Let's do the y. So we are going to sum forces along the y. Every force going up should be positive. Okay. So starting with the first value, we got so 80 sine 40, which was what? 51.42. So 51.42. And then the second one was what? 112.76 plus 86.04. Okay. Okay. So now when we add, what do we get? Again, let's pick our calculators. Okay. So 51.42 plus 112 point what? 76, isn't it? Plus what? 86.04. So what is it then? Please pick your calculators and convince yourself that whatever we are doing here is correct. Okay. So 250 point what? 22. Okay. 250.22 newtons. All right. So I've got the S component and then I've got the Y component. Is that right? Now, how do you find the resultant? Okay. So this is what we are going to do. So this is how we are going to do it. Now we know that our y-axis is here, and then we have our x-axis, isn't it? Now, the s component is what? The s component is what? Minus 20.55, isn't it? So minus 20.55. So I'll go to the s component, then I'll come here. So minus 20.55 is somewhere along here, because this is the opposite of the positive x. So 20.55. And then the y component is 250.22. 250.22, sorry. So I have so 250 point what? 22. Is that right? Now, if I want the magnitude, then I'm going to use the Pythagoras theorem, isn't it? So the magnitude or the resultant is nothing but the hypotenuse of this triangle. Now, at this juncture, we are going to use the parallelogram, the Pythagoras theorem, yeah. And this is going to be the angle, okay. So now, let's use Pythagoras. So Pythagoras is saying that the magnitude of this triangle, which is the square of the hypotenuse, is going to be what? The sum of the squares of the other sides, which is what? 20.55 squared plus what? 250.22 squared. Is that right? So the resultant is nothing but the square root of whatever is here. All right. So now let's take the square root. What is it? So 20.55 plus 250.22. I need to square this. All right. So the magnitude or the resultant force is going to be what? 251 point what? 06. Okay. So 251.06 newtons. As a matter of fact, what this means is that we can represent the whole of these three forces with just a single force, whose magnitude is equivalent to all of the three forces. Essentially, that is what it means. And then that is what? 251.06. And that is what? The magnitude. All right. So now, at this juncture, I want us to look for the angle. Okay, let's look at the angle. Okay, so let's look for theta. So the Pythagoras theorem will give us the magnitude. And if I want theta, what do? I go back to my trigonometric ratios. Is that right? Now, using our trigonometric ratios, tan theta is going to be what? Tan theta, isn't it? Okay. By the way, we can use sine or cosine, right? But in fact, you can use tan because you know x, you know y straight away. Okay. So tan theta is nothing but 250.22 divided by 20.55. So theta is going to be what? Tan inverse, isn't it? So what is it then? So theta is going to be tan inverse of 250.22 All right. So please, let's take our calculators one more time. And what is it? Please, let's pick our calculators. So we are going to, the tan inverse of, okay, let me. Okay. So tan inverse So tan inverse of 250.22, then I divided by what? 20.55, right? And what is that? So that's going to give me what? 85.30. Let's say 305. Okay. 85.305. So this problem has been solved. All right. So this problem has been solved. Now we know the magnitude of the force, and then we also know the angle. All right. So now I want us to look at one more problem under resolution of forces, and then I'll move to equilibrium of particles in 2 dimensions. So one more problem. Okay, let's look at this problem. All right, so let's look at this problem. I hope we are learning together. All right. Okay. So from this question, knowing that alpha is 35, determine the resultant of what? Of the three forces. Okay. Okay. So then let's start. So we are going to start from the 100 Newton force. This one. Okay. So let's start with this 100 Newton force. Um so I want to do this with you. Watch this. Now the axis is here. Okay. So starting with the 100 Newton force. So this is our x-axis. But let's do something. Let's try to create an arbitrary y-axis here. Okay. So then what is it going to be? We know that alpha is 35, isn't it? So now if alpha is 35, then so the s component, right? The s component so the s component is going to what? But before we do this, let's try and create a convention. So plus y plus x. So basically what this is trying to tell us is that any force in this direction is positive, and then any force in this direction along the y is what? Positive. Okay. So the x component fx is going to what? So fx is going to be 100 cosine 35. But is it plus or minus? That is the question we have to ask ourselves. Is it plus or minus? Now, it's going to be plus because the line of action of the force along the x is coming this way. Okay. But the y component of the force will come down like this. Okay. Now, because the y component is coming down, then it's going to be against the positive y-axis, right? Okay. But then let's calculate the value for the x-axis. And what is it? 100 cosine 35. So please pick your calculators. 100 cosine 35. What is it? 100 cosine 35. $81.92. Newtons. Okay. And then let's look at the y-axis. Fy is going to what? But this time around is going to what? Negative y, because the y-axis, the y component of the force is moving down, right? So it's going to what? Minus 100 sine of what? 35. Okay. Now let's pick our calculators and punch this. So what is it then? So minus 100 sine 35. So 100 sine 35. Okay. And what do we get? So the answer is 57.35. So minus 57 point what? Okay, let's say 36. So we've been able to calculate Fx and Fy for the 100 Newton force. Is that right? Okay. All right. So now let's come back to the 150 force. So now we are done with the 100 Newton force. So now we are doing the 150 Newton force. Okay. So now, so please ignore that there is 100 Newton force here. Ignore it. And just let's look at 150 for now. So the whole of this angle here is what? alpha plus 30 degrees, isn't it? And what is that? Alpha is 35. So if I add 35 to 30 degrees, that what is it then? It's going to be what? 65, isn't it? Because I know that 35 plus 30 will always be 65. Okay. So now with a 150 Newton force, is what? It's going to be, so again the x component is going to be positive. So it's going to be fx. Okay, so fx is what? 150 cosine what? 65. All right, so that is the s component. So let's pick our calculators. Let's pick our calculators. Okay. So then what is it? So 150 cosine 65. So 63 point what? 63.39. Okay. So 63.39. So that is x component. Let's look at the y component. Let's look at the y component. So the y component, let's go back to the diagram. Okay, so from the diagram, we can clearly see that this is the angle and then this is the force. So picture this as, let's say 150 is coming here and then it has an x component here. So the y component is going to come down like that, isn't it? So this is going to be 65 and this is 150 newtons. So now this side is going to be opposite and this side is going to be what? Adjacent. Now the y component is going to be negative. Why? Because it is coming vertically downwards. Is that right? So then Fy is nothing but so minus 150 sine what? 65. Is that right? Okay. Okay, so Fy is going to be what? 150 sine 65. What is it? Okay. So 150 sine 65. And what is that? 135.95 minus 135.95 newtons. Okay, so that is the y component, all right? Okay. Okay, now let's look at the 200 Newton force. Okay. So with the 200 Newton force, again, you can see that the angle it makes with the x-axis is alpha, right? Okay. So watch this. Now, if I want to find the x component and the y component, the x component is going to come this way, and then the y component is going to come downwards. All right. So then the x component. Now watch this. For this force, the x component is going this way, and the y component is also going down, right? So because of that, it makes the whole of that what negative, isn't it? So it's going to be fx minus what? So minus 200 cosine alpha, which is what? 35. And what is that? So then fx is what? So let's punch it. So 200 cosine 35. And what is that? All right. So minus 163.83, isn't it? So minus 163 point what? 83. How about the y? So the y axis, so for the y is going to be again 200. So minus 200 sine 35. Is that right? And what do we get? And what is that? So 200 sine 35. So we are going to get 114.72. Okay. So 114.72 minus 114.72. So I want to give you a tax here. 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . 114.72 . Take your time and sum all the forces along the x and put them together. So which is 81.92 plus 63.39 minus 163.83. So I am not going to do that for you. Please try your hands and add them. Again, on the y-axis, so minus 57.36 minus 135.95 minus 114.72. Now, whatever you get, so your x, your y, okay? Okay, now, please, at this juncture, I want us to move to equilibrium of particle. Okay, we are going to solve some problems under equilibrium of particle, and then I'll move to forces in space, 3D forces, and then we will do some moment questions, and maybe we can end today, so that in the next time when we come, we are going to focus on the trusses only, and then we will do the method of joint and the method of section, and then we will also look at centroids. All right. Okay, so now I want us to move to equilibrium of particles. So I've got several problems. Okay, maybe let's look at this one first. All right. So let's look at this problem together. Let's look at this problem together. So we want to look at equilibrium of particles, okay? So we are basically looking at equilibrium of a particle. Okay. All right. So now, for a particle to be in equilibrium, what are the main conditions? For a particle to be in equilibrium, we need to satisfy at least okay, so the summation of forces in all direction is supposed to be zero. The summation of forces in all direction in all directions. The summation of forces supposed to be zero. Now, since we are dealing with the two dimension, then we are talking about the x and the y directions. So we can reframe it and say that, okay, so summation of force along the x is zero, and then summation of forces along the y is also what? Zero. Equation 1, equation 2. So these two equations are necessary and sufficient for a particle to be in equilibrium. And this will help us to find any unknown that we want to find. So now the question said that we should determine the magnitude of F1 and then the angles theta for equilibrium. And then we should set F2 to 6 kilonewtons. Is that right? So now basically we are going to sum all the forces to zero, and then we are going to find the unknown force. Is that right? So let's start from F1. Okay, this is F1. Okay, now F1 makes an angle of theta with the x-axis. Okay, this one is theta. Now the x-axis is here, but what do you see? The y component. So okay, so the x component is going to come here, but the y component will come vertically downwards like this, which means that for this configuration, or for this force, the x, okay, so let me draw the convention again. So the convention is that every force x plus y plus. So every force in this direction is positive, and every force in this direction is also positive. Okay. So let's start with the F1. We don't know F1. We've been asked to find the magnitude of F1. So it's going to what? F1 cosine theta. Is that right? So now we are looking at summation of force along the x. Now watch this. F2 is making an angle of what? 70, but what? With the y-axis, isn't it? So since it's making an angle with the y-axis, then so what is it? Let's see. So the x component of F2, is going to come this way. The y component will move along the y. Now, interestingly, the 70 degree here is opposite to the x. So now this time around, the x component of F2 is going to what? It's going to be F2 sine 70. Is that right? Because the 70 degrees is opposite. So plus F2, which is 6 sine what? 70. Is that right? All right. Now again with the 5 kilonewton here, the angle is what, 30 degrees. And now watch this. You can see that the angle that the force makes with the x-axis is what? 30 degrees. But the s component will come somewhere here. And then the y component will go up like this. So for the 5 kilonewton force, the s component is going to be minus. And that is what? Minus what? 5 cosine what? 30. Because it is what? Adjacent. So please take notice of this. Whenever the angle is opposite to the side, it is what? Sine. And whenever the angle is adjacent to the side, it is what? Cosine. Is that right? All right. Okay. So then with the 70 with the 7, now we see something interesting here. We see a force and then we can see a small triangle on it. But it is actually easy. So this is how you can solve this. All right. Okay, so if I want to get the s component, so to get the s component, what do we have to do? It is nothing but minus, because if I resolve this, the s component is going to come the same way, but the y will come downwards. Is that right? Now this is how you are going to solve this. Look at the small triangle right here. It has got a hypotenuse of 5, and then the horizontal side is 4, and then the vertical side is 3, right? So to get the s component is going to be the horizontal side, which is 4, divided by the vertical side, which is 3. The horizontal side, which is 4, divided by the hypotenuse. Yeah. Then you multiply this with the magnitude of the force. That's all. Okay. So now let's so what is it going to be? We are done with summation of all of the forces. So what is it going to be then? So what is it going to be then from here? So we are going to equate it to 0. Why are we equating to 0? Why are we equating to 0? We said earlier on that for a particle to be in equilibrium, then the summation of all of the forces must be 0. And therefore, we need to equate the summation of all of the forces to 0. Isn't it? All right. So we are going to some forces. So let's call this equation 1. Let's try and simplify it as much as we can. So F1 cos theta. Let's sum everything here. Let's try and put everything together. So 6 sine 70 so 6 sine 70 and then minus what? 5 cos 30, right? So 5 cos 30 and then what? Minus 4 on 5. So 4 on 5 multiply by what? 7. So minus what? 4.29. Okay. So I'll bring the 4.29 here and it becomes positive. 4.29. So let's call this equation 1. Okay. So we are done with summation of forces along the x. Now we are going to do summation of forces along the y, but it's going to be very easy. Is that right? So looking at summation of forces along the y, starting from F1, the y component of F1 is going to be negative, right? Because it is coming down. So minus F1 sine theta. Okay. And then F2 is going to what? So now F2 is what? Okay. So 6 kilonewtons is here. Now the y component is along the y-axis. But interestingly, the angle is adjacent. So for the y component of F2 is going to be what? Cosine. Interesting. So please, this means that you don't have to always memorize that, oh, the x-axis is cosine and the y-axis is sine. No. If the angle is adjacent, it is what? Cosine. And if the angle is opposite to the side, it is what? Sine. So this one is going to be what? Cosine. So cosine 70, right? So plus 6 cosine 70. Okay. So 6 cosine 70 isn't it? And then 5 kilonewton so minus plus, because the 5 kilonewtons will be going up. Okay. So now since the 5 kilonewton is going up, what is going to happen? So it's going to be sine for this one. So plus 5 sine 30. So plus 5 sine 30. Is that right? Then the last one to look at is that force which is there, the 7 kilonewton force. So minus what? So this time around, if you want the vertical side, so using this triangle, sometimes in mechanics questions, you see the triangle. Instead of giving the angle, you see the triangle. So if you have the triangle, that is how we solve it. So that one is going to be minus what? So it's going to be the vertical side, which is 3, divided by what? The hypotenuse, which is 5. Then multiply by what? 7. Is that right? And this should be equal to what? 0. Okay. Equation what? 2. Okay. Let's try and simplify it. So minus f1 sine theta. Let's try and simplify what we have here. So it's going to be what? 6 cosine 70 plus 5 sine 30 minus 3 divided by 5 multiplied by what? So multiply by 7. So 0.352. So plus what? 0.352 to be 0. So it implies that f1 sine theta is what? 0.352. Let's call this equation 2. Okay. So let's call this equation 2. All right. So now what will we do from here? So basically you have got an equation involved cos theta and sine theta. So how can you solve this equation? So it's going to be f1. Okay, let's so this is how we are going to solve it. Equation 2 divided by equation 1. Okay. And what is that? F1 sine theta F1 cos theta should be equal to what? 0.35 divided by what? 4.29. Now, when I do this, so tan inverse of what? So tan inverse of what? So tan inverse, don't forget that. So please don't forget that sine theta divided by cos theta is tan, right? Okay. Okay. So tan inverse of 0.352 divided by 4.29. Now, what is theta? So tan inverse of 0.352. Okay. $4.29. Okay. So 0.352 divided by 4.29. So tan inverse of that, is that right? So you are going to get 4.69. So the angle is 4.69. Okay. Now getting 4.69 as an angle, you can go back into the equation and put it inside. Either cosine or sine. So for instance, if we know that F1 sine 4.69 is 0.352, then from here we can find F1 what, right? All right. So F1 is what? 0.352. Uh, so what is it then? Um, Divided by what? Okay, 4.6. No, wait. Divided by sine 4.69. Okay. So what do you get? 0.352 divided by sine 4.69. What is that? So it means that F1 is what? 4.305. Let's say 4.31 kilonewton. So now we have the force F1 as what? 4.31 kilonewton. Okay, so the force we know, and then the angle too we know. So now this is how you solve a question like this. Now let's solve one last problem. Okay, so this problem too is similar. I'm not going to solve with you. I will just walk through with you because we just did something similar to this one. So quickly, let me just start with the question and then I will let you continue. Okay. So we've been asked to find F1 and the angle phi. So you see that the same thing, isn't it? So you are just going to resolve it. Is that right? So looking at the forces along the x, every force in this side is positive. So let me put it this way. So F1 cosine phi, right? And then F2 is making an angle of what? 60 with the x. So minus what? Sorry, it's going to be plus. So plus what? 500 cosine 60. And then this last one is coming here, this force. But the s component of this force will come this way. Is that right? Now the s component, because it's coming that way, is going to be negative, and that is what? 3 on 5. And then you are going to multiply this by what? 450. Is that right? To be 0. Are we together? Okay. All right. So then and then let me do the y component. Sorry. So F1, so the x component will be 0 and the y component will also be 0. So F1 sine phi so but then you look at this, you see that the F2, the y component is going to come down, isn't it? So minus what? 500 sine 60 And similarly, the y component of this one is going to come down. So minus, isn't it? So minus what? 4/5 multiply by what? 450. Should be equal to 0. Okay. So please, I want you to do this. I want you to do this on your own. So you take your time, you sum forces equal to 0. Is that right? I want us to look at forces in space, 3D forces. Let's look at 3D forces. Forces in space. Let's look at forces in space. And then I will look at moment because of our time, so that I will close around 9 p.m. and then we will find some other time and continue from where we ended. Is that right? Okay. Okay. So now I want us to look at forces in space. 3 dimension. So let's start with this problem. All right. So this is how we are going to start. This is actually a simple question which we are going to solve. All right. So this is how we start. There are some equations that we need to know before we can be able to solve. There are some equations that we need to know. All right. Okay, so these are the equations that we need to know. Number one, whenever I have a force in space as a vector f, it has got a component fx along the I direction, which is the unit vector along the x direction, plus a component fy along the j, which is a unit vector along the y direction. Finally, plus fz Um, so the component of the force is Fx along the x, Fy along the y, Fz along the z. But the I, J, K are basically the unit vectors which are associated with the, we call them unit directional vectors. Yeah. Associated with the force. Okay. So now this is how you are going to do it. This is equation 1. Now what this means is that if we want to find the magnitude of the force in space, it is going to be the square root of the square along the x plus the square along the y plus the square along the z. If I do this, I will be able to find the magnitude of the force in space. Okay. So now this is how you are going to do this one. First of all, oh no, but wait, this is equation 2. There is another equation which we need to know, and that equation is that the cosine, so we call something directional cosines, okay? We call something directional cosines. Now, when we say directional cosines simply means that the cosine of the angle along the x, so let me do it this way, cos square theta x plus cos square theta y plus cos square theta z should always be equal to what? 1. Now, these 3 equations are very important if you want to solve a question in 3D. This is very important. Okay. These equations are the basic and the fundamental equations which you need to be able to solve a 3D problem. These are the basic and the fundamental equations. There are other ones, but it depends on the question. But for a 3D typical question, these are the equations that you are going to use. Okay. All right. So let's start with the let's start with the question. The question said determine the magnitude and the direction of the force. So this is the magnitude, this is the direction of this force. Okay. Sorry, this is the this is just the force represented as XYZ. Our task is to find the magnitude and the direction. Okay. So the magnitude, okay, so let's express the let's try and find the component. Okay. So if I compare the equation 1 with the force So Fx is going to be 320 newtons. Fy is going to be what? 400 newtons. And then finally, Fz is what? Minus 250. So essentially, what we are doing is that we are basically comparing this together with this. The I is what? 320. The J component is what? 400. And then the K component what? Minus 250. Is that right? All right. Okay, so now the magnitude of the force is going to be the square root of what? Using this formula, the second formula. So using the second formula, it's going to be what? 320 squared plus what? 400 squared plus what? Minus 250 squared, isn't it? So now the magnitude is nothing but the square root of that. Let's pick our calculators and do that. So square root of what? 320 squared plus 400 squared plus what? Minus 250 squared. So we get 570. So the magnitude of the force is what? 570 newtons. Okay, so now what we are going to do is that at this juncture, we are going to find the direction. You see, the question said find the magnitude and the direction. So now it means that we need to go and we would also find the direction as well, isn't it? So let's try and find the direction as well. Okay. So let's get the angles first. Let's get the angles first. Now there is a fourth equation. I think I didn't write that one. Let me add it now. There is a fourth equation. So F cosine theta x along the I plus F cosine theta y along the G plus F cosine theta z plus K should be equal to okay, should be equal to F as a vector. Let me bring it down here so that you get it. Okay. So what we are trying to say is that whenever I have a force and I know the magnitude, I can express the force and the magnitude as in terms of cosine of the angles. So for instance, 570 cosine theta x along the I plus 570 cosine theta y along the G plus 570 cosine theta z along the K. Is that right? So this equation is also equation 4, which is also one of the fundamental equations which you have to use in order to actually you know solve for the angles. Okay. All right. Now if I so let's do something here. We are going to do a comparison. So this is how it's going to be. Let's try to compare this with this. So we have fx. So fx is what? I want us to do this. We are going to pick the x component, y component, and the g component. Then we are going to compare. So if we compare, it's going to be 320 I plus what? 400 G minus what? 250 K. Now comparing equations, comparing the equations, these two equations, you can see that 570 cos theta x is the same as 320, right? And then you can also see that 570 cos theta y is what? It's 400. And finally, 5. Okay, you let me take my time and do it one by one. So let's start with the first one, the x component. From here, I can say that what? Cos theta x is what? 320 over 570. And what is that? It means that theta x so theta x is nothing but what? Cosine inverse of what? 320 on 570. And what is that? So cosine inverse of what? 320 divided by what? 570. And what is that? 55.85. So that is theta x. Okay. So cos theta y is what? 400 divided by what? 570. Right? So I can say that theta y is what? Cosine inverse of what? 400 over what? 570. And what is that? So now taking the cosine inverse of that, what do you get? You get 45.43, right? So my theta x is here, my theta y is here, and then now let's find theta z. So I can also say that 570 cosine theta z must be the same as the z component. And what is that? The z component was what? Minus 250, right? So cos theta z so it's going to be what? Cos theta z is what? Minus 250 minus 250 divided by 570. So therefore it means that theta z is going to be what? Cosine inverse of what? Minus 250 on 570. So it's going to what? So then cosine inverse of what? Minus 250 divided by what? 570. And what is that? 116.0. So in fact, this question is to demonstrate that whenever you have a force in space, it has a component along the x, along the y, and then along the z. And these components are related by the equations which we wrote initially. And whenever they give you a question and then only one of the angles is given, or maybe let's say that you have been given two of the angles, and then you need one of the angles, you use the equation, right? But when you have every angle, and then maybe let's say you have the forces, you want to just find the magnitude, that one you are going to use the second equation. All right. Okay, so please, because of time, let's take one moment question. But in the next meeting, I will come back to the 3D force again, and maybe take one question more, and then we are going to look at moment Again, then I'll move to equilibrium of rigid bodies. Then we will set into the trusses. Okay. Okay, let's look at this moment question and then we will end. Okay, let's look at this moment question and then we will end. Now, after the tutorial, I'm going to leave the link below. I've done several videos on some of these concepts, so that's why I don't really go through several problems, because I have done the videos for all of the concepts. So I'll just leave the link so that you can find some time and go through. Okay. All right. Let's solve this question quickly. All right. So in this question, okay, so we've been asked to determine the resultant moment of the four forces acting on the rod. Okay, so we are just going to basically find the moment of the forces about O. So that's the keyword, about point O. Okay. All right. So first of all, in moments, there are two things you need to know. Whenever you are solving a moment question, there are two things you need to know. Whether you are doing anti-clockwise or you are doing clockwise. Okay. Now, when we say anti-clockwise or clockwise, what happens is that so when the moment was discovered, there was a sign convention at that time. Okay. But to describe the direction, what they did was that, okay, let's use the clock. So if the clock is turning, okay, let me demonstrate this so that you get it easily. Let's say I have a clock here. Okay, let's say I have a clock. If the hour, let's say this is the hour, let's say the longest one is the minute, right? Then we come to the hour, right? Ideally, if you have a clock, you expect that the clock will rotate in this sense, right? So you expect that the clock will be turning in this direction. So if you have something like this, we call it clockwise, okay? So when we say clockwise movement, it means that the direction of the rotation is in the sense of the clock, right? It is moving in the direction of the clock. Is that right? However, if the rotation is going against, so if the rotation is going against the way the clock will go, then we call that what? Counterclockwise or anti-clockwise. I hope the concept is clear. All right. All right. So now, having known this, let's solve the question now. So one thing you have to also notice that moment of a force is the turning effect of a force. In other words, whenever we are looking at moment of a force, then we are calculating the ability of the force to rotate the body. Okay. All right. Let's solve this question. So we are going to sum moment about O, but we need to choose a convention. Now the convention is that we can say that, okay, every force, every moment counterclockwise is positive. Okay. So the choice is yours. You can say that counterclockwise is negative or counterclockwise is positive. But I am saying that counterclockwise is what? So I am saying that counterclockwise is positive. But you can also choose something different from that. Is that right? All right. Okay. So now we are going to say we are going to solve it, and then we will close for today. So first of all, let's start with the 50 Newton force. Okay. Now the 50 Newton force is going this way. The line of action is going this way. Is that right? Now think about it this way. Think about it this way. Let's say there was a rod somewhere here, and then the force was coming downwards. What do you expect? You would expect that this force will what? Rotate the rod in that sense. Is that right? And that sense is what? That sense is clockwise. So minus 50 times 2. By the way, moment is force times perpendicular distance. Right? Okay. Now look at this 60 Newton force. Look at this force. 60 Newton. The line of action is passing through O. Okay? It's passing through O. So think about this force as, let's say you are standing at the door. Okay? Let's say you are standing in front of a door, and then you want to open the door. But instead of you to hold the handle and apply the force perpendicular to you, you stand at one edge of the door and push on the door like this. It will never open unless you hold the handle and push it in the direction perpendicular to you. So in other words, the line of action of the 60 Newton force is passing through O, therefore it creates no moment. So interestingly, since the line of action passes through O, then the moment is what? Is zero. We don't need to worry ourselves. Is that right? Okay. So now, this is what we are going to do. Now, we need to do, first of all, okay, so I've explained the 60. All right. Now, we have a 20 Newton force here, okay? The line of action of the 20 Newton force is going this way. Is that clear? Since the line of action is coming this way, then we need to find the perpendicular distance. Okay, so let me explain this. We call it the principle of transmissibility. The principle of transmissibility. Transmissibility. Now, this principle of transmissibility allows us to transmit a force. So, transmissibility, ability to transmit. Is that right? So, transmissibility means ability to transmit a force along a line or a straight line. Now, what that principle is saying is that if I have a force which is 20 newtons here, then the force is acting along a straight line. So, therefore, to find the moment about O, we can even say that the force is 20 newtons here. So that we just need a distance from there to here. And what is that distance? In fact, interestingly, to get that distance, it means that we would have to resolve the 3 meters here. So you see that there is 3 meters here, the pipe bend, isn't it? The rod. You can see that 3 meters is here. So to get the perpendicular, let's say you have something like this. So to resolve and get this side, here is 30 and here is 3, isn't it? So this side from here to here is going to be what? 3 sine what? 30. Is that right? Okay. So it means that, but then wait. Ask yourself, if this force is here, let's say there is a rigid rod here, and the force was coming this way, okay? What will happen? You see that it will push it in this sense, and then it will send it that way, right? So counterclockwise. So plus what? Plus 20 multiplied by 3 sine what? 30. Is that right? Okay. Okay. Very good. Very good. Very good. Very good. Now, finally, this is 40 newtons, isn't it? Now, the line of action of the 40 newtons is coming vertically downwards like this. And then as it is coming, if you draw a perpendicular line from O, it will meet it and come and touch it here. Okay? It will come and touch it here. Now, the question is, what is the perpendicular distance? What is the whole of this distance here? So, what is the whole of this distance here? All the way here. All the way up to this point. What is it? All right. So, the distance, so we know that here is 2, here is also 2, right? But what is that distance here? From here to here? It is interesting to know that if we resolve the horizontal distance of the pipe, the bent part, it is also going to be 3 cosine what? 30. Now, can't you see that this is interesting? Because now it's going to be 2 plus 2 plus what? 3 cosine 30. And that is the perpendicular distance for the 40 from O. But what is it? Clearly, you can see that if I have a rod here and there is a force which is coming this way, it is going to rotate it this way. And that is what? Clockwise. So minus, the force is what? 40 newtons. And the distance is what? 2 plus 2 plus 3 cosine 30. Okay. So let's quickly do this and then we close for the day. All right. So what is it going to be? Let's pick our calculators. Let's do this quickly. Let's do this quickly because of our time. So minus 50 multiplied by 2, yeah, plus 20 multiplied by 3 sine 30, and then minus 40 multiplied by 2 plus 3 cosine 30. Is that right? What is it then? So the answer is 333.92. So minus 333.92 Newton meter. Now the fact that we are getting negative is trying to tell us that because we are getting negative, then the moment is what? Positive. Because we said counterclockwise should be positive. But if we solve and then we get negative, then it is clockwise. So you can either bring this symbol or you can write clockwise. Or sometimes some people also like writing it as CW. So that is it. So please, thank you very much for watching. I'm going to leave the link below for the playlist in basic mechanics. I'm still updating the playlist, so find some time and then you can solve a lot of problems. We will schedule another time. Thank you very much for watching and then staying with me here. Please enjoy the rest of your night. So thank you very much. I will let you know the next meeting, the time and the date. All right. So please, thank you. Thank you for watching. Thank you, everyone. So I'm ending the broadcast now. Thank you. But if you have a question, please, you can leave it in the comment box or you can personally talk to me. I'll leave my details. You can personally talk to me and then we can look at it together. Okay. Thank you.